Requiem maintenance, forged for performance.
Alright, today we're dealing with a more serious problem on one of my client SCJ Kashi machines. The hydraulic pump wasn't starting and the entire machine was down. When I arrived, I noticed a hydraulic leak coming from the diagnosing cylinder, and some oil had made its way onto the three-phase motor that drives the hydraulic pump. The motor is quite old, so I wasn't sure if the leak caused the issue, but it definitely didn't help. I started troubleshooting to see what was really going on. After checking the motor, I found all three phases shorted to ground. This is clear signs of internal damage while inspecting the control circuit. I also discovered that one of the Delta Star contactors was stuck, so I disassembled it, cleaned the contacts, and freed the mechanism. After that, I replaced the damaged motor, reinstalled the contactor, and fixed the hydraulic leak. What seemed like a simple fault turned out to be much more involved. So let's go through it together and see how we brought this machine back to life. I start the inspection by measuring the motor and looking for resistances of it, and boom. Right away, I see that all three phases are shorted to ground, a clear sign that the motor is burned internally. There's no point in trying to make more serious tests. It needs to be replaced. Next, I check the Delta Star contactor configuration that controls the motor start sequence. The main contactor was stuck in the closed position. They could easily have caused issues during startup or protection trips. I carefully disassemble it, clean the internal contacts, check the spring mechanisms, and test the coil. After reassembly, the contactor moves freely again and is ready to go back in service. To reach the motor, I need to remove the rear hydraulic group. While doing that, I also take the opportunity to fix the leak on the declos cylinder. I remove the back cover of the cylinder, replace the damaged seals, and clean the area thoroughly. With that done, there's more space to remove the motor safely. The seal may look small, but once it fails, the hydraulic oil starts leaking and can create much bigger issues down the line. Now I can disconnect and take out the old motor. It's heavy and tight in the frame, so I move slowly to avoid damaging the coupling or hydraulic lines. After the motor is out, I clean the bell housing and prepare the mounting area for installation. I also drill a small access hole above the coupling area to insert my endoscopic camera. This will help me see the alignment between the pump and the motor shaft when installing the new unit. And I change the rubber connection between the motor and the pump couple. Now it's time to mount the coupling between the motor and the pump. Let's take out and assemble it on the new motor together. Before mounting, I take all necessary measurements on the new motor, check alignment, and verify that the shaft rotation and dimensions match exactly. With everything ready, it's time to install the new motor. I have to be very careful when inserting the engine as the space is very small, but with great care I managed to get into the insertion position. Using the endoscopic camera, I align the coupling precisely with the pump shaft until it seats perfectly. Once it's coupled, I secure the bolts evenly and double check that the shaft turns freely and it's good to work. I fix the motor completely in place and tighten all mounting bolts to specification. Then I reconnect the pump and confirm that there's no mechanical stress on the coupling. Next, I reinstalled the repaired contactor back into the control cabinet. I make sure it has seated correctly on the rail and that the coil wiring is in good condition. Since this unit was previously stuck, I double-check the mechanical movement to confirm it engages smoothly. After that, I reconnect all electrical cables to the new motor phase lines, grounding, and control wiring. I take a moment to verify the phase order and measure insulation resistance to ensure there's no leakage to ground. Every connection is tightened properly and inspected visually before I close the cabinet and prepare for the first test run. With the system powered on, I let the motor run for a few minutes. I need to make sure the pump is primed properly. The mechanical system has no play, and there are no strange sounds in this area. For the next stage, I will use my thermal camera to inspect the electrical installation. I check each connection point on the contactors, terminals, and cables. The temperature looks balanced across all three phases with no hot spots or unusual readings. This confirms that the contactor repair and new motor connections are working perfectly with stable electrical performance. The repair is complete and the die casting machine is running smoothly once again. From a burned motor to a hydraulic leak and a stuck contactor, every issue was identified, repaired, and tested step by step. Regular inspection and quick intervention can prevent long downtime and protect your equipment from serious damage. Thanks for watching. If you enjoy real maintenance and repair work like this, don't forget to like the video, subscribe, and stay tuned for the next project.